Theorem 2, angle at the center is 2 times angle at the circumference. Theorem 3, an angle subtended by a diameter at the circumference is equal to 90 degrees. And the shortcut we say angle in a semicircle. Theorem 4, angles in the same segment. Okay? So if you have got angles that are subtended by the same chord at the circumference and they are in the same segment, those two angles will be equal. Okay, so this homework here, you are supposed to use either Theorem 2, Theorem 3, or Theorem 4. Theorem 2, Theorem 3, or Theorem 4. Plus your knowledge of geometry of triangles from lower grades, grade 8 to 10. Triangles are very, very important in geometry, and you will see them in almost every question. You see a triangle. And by now, all of you should know that the 3 interior angles in a triangle add up to what? 180. Okay? You don't need to be told that now. All right? So let's just go over the question. So this one was the first one. Okay? Now, when you're answering the geometry questions, I would suggest that you have a highlighter so that you can be able to indicate things on the diagram. Okay? So if you look at the question, there is a center. The fact that the center is given, it's a clue that somehow you might need to use one of the center theorems. Okay? If the center is given, it's a clue that somehow you might have to use one of the center theorems. Also, look for butterflies. Okay? In this diagram here, of course we've got a butterfly, but the problem is angle O2 is not at the circumference. So you can't use Theorem 4. So for this question, Theorem 4, you throw it outside. So you only have Theorem 2 and probably Theorem what? 3 to use for this question. Plus your knowledge of triangles. You must know where to start. You must have a strategy, and that will make geometry easy for you. Yes? Sorry? If you're talking to me, I need eye contact. Okay? I need eye contact. You've never seen me talking to you like that. If I were to do that, I will hear a complaint. Then speak up as well. Okay, it will only become a triangle if you join point P to point S. Right, I'm not sure how you did the question, but whichever way you did the question, hopefully you use the correct geometry concepts. Okay? So in my case, I want to calculate angle O2. This is O2. Okay? Angle O2 and angle O1, they are angles on a straight line. So if I want to determine O2, I have to determine O1 first. Okay? So the question will be, which chord subtends angle 1? It's going to be this chord here. Chord what? PS. It's an invisible chord, by the way. But you can just join those 2 points using a pencil or a highlighter, whichever the case. Right? So angle O1 is subtended at the center by chord PS or by arc PS. Okay? Now, the same chord, you must also check, does it subtend any other angle?
Yes.
Huh? Which angle?
M1.
M1. You're almost done now. So, angle at the center, O1, is 2 times angle at the circumference, which is M1. Okay? So, I'm going to write it down here. So first, we are going to say angle O1 is equal to 2 times angle M1. Okay? And then you give your reason here, angle at center is equal to 2 times angle at circumference. Both angles O1 and angle M1 are subtended by the same chord. The word subtended means that the two lines which form both angles, the two lines, in this case here, to form angle O1, you need line OP, you need OS. Those two lines, they originate from up PS or chord PS. The two lines which form O1, they originate from up PS, or you can say chord what? PS. So in geometry we say PS subtends, which means it's like the anchor of this angle here. Without PS, that is the chord or the arc, angle O1 cannot exist. Are you following that? Yeah, because you are going to hear me a lot talking about subtended. You need to know what that means. Okay? Furthermore, if you look at angle O1, there is this line here. It's a chord, MP. It originates from PS. Okay? So both angles are subtended by the same chord, or they are subtended by the same arc. Therefore, the angle which is at the center, it is 2 times the angle which is at the circumference. All right? Okay, so we are here. So this is easy now. So you get 2 times 53, and you get 106 degrees. Okay? Now I found O1. But O1 and O2, they are angles on a straight line. So I have to write down, then I'll say, but O1 plus O2, they add up to 180. And you must provide the reason why you say they add up to 180. The reason is angles on a straight line. Okay? So I want to get O2. O2 will be equal to 180 minus 106. Right, when I was moving around, I saw some of you with the answer, correct answer. So the correct answer will be 74 degrees. Okay? Whatever statement you write, you must give a reason for it. Whatever statement you write, you must give a reason for it. And I also need to warn you that this topic is so important in geometry. It's one of the most important topics in all your high school career, this topic. And you have to love it like me. Okay? You have to love it like me. And it's not difficult, it's an easy topic. You need to have the right attitude. Okay? Don't surround yourself with people who tell you that geometry is difficult. It's not difficult, it's easy. Right? Okay. Any questions? Anybody who has got a question? If you don't have a question, then let's move on to the next one. Okay. Now again, first thing, if you are given a center, as long as the question has got a center, what must come into your mind? One of the center theorems. If the question is talking about angles, throw away theorem 1. If the question is talking about finding lengths, if there is a line which passes through the center, throw away theorem 2, 3, and 4. You focus on theorem what? 1. If you do that, you might find things a bit easier for you. Okay? You must have a strategy. Don't answer geometry questions without knowing where to start. Okay? So we have got a center here. Then you also check, is there a butterfly? Okay, it is there. So we have got our butterfly here. That's our butterfly. Which means I have to apply theorem 4. somehow. Okay? Also, we have a diameter, Mn, which means I have to apply theorem 3. The diameter is there. There are triangles, which means I might need to use geometry of triangles. Okay? Because there is also a center, angle O2 or O1, I might need to use theorem 2. So this whole question here, it has got, it requires application of the center theorems, theorem 2, 3, and 4. Okay? So let's find O2. Now, because O2 is at the center, there is a chord or an arc which subtends it. Okay? Identify that chord or arc. So O2 is this angle. So O2 is that angle. I'm gonna get O2, right? It is subtended by EN. Now, does EN subtend any other angle at the circumference? M2 subtends M2. Okay? Let me indicate that they are not the same. Okay? So chord EN subtends two angles, O2 at the center and M2 at the circumference. Now, based on the question, we are given the size of M2. So I'm almost done. Okay? I'm almost done. So I can just write here quickly. O2 is equal to, it's going to be equal to 2 times M2. And my receive angle at center is equal to 2 times angle at circumference. So that angle there is going to be equal to, all right, okay, let me duplicate this page because I might need some of the stuff. Okay. So it means angle O2 is going to be 2 times 55. And the answer that you get there is going to be 110 degrees. Okay? It's going to be 110 degrees. So that's the answer for 7.1. Okay? Yes? What? What triangle are you talking about? You want me to start afresh? Okay, I need you to be aware that this question, to calculate O2, this is not the only way, but this is the shortest way. There is a longer way though, but I'll share with you. Okay? There is a longer way to do it. So here, okay, angle O2, it is at the center. Which chord subtends it? It's called EN. So this chord EN subtends angle O2 at the center. Does the same chord subtend an angle at the circumference? Answer is yes. It subtends this angle. Okay, how do you see that? Well, you have to see it. Okay? Yeah. If you can't see it, you're going to have problems. So, angle M2, it is subtended by that diameter. Sorry, it's formed by this diameter and line EM. Both these two lines, ME and the diameter, they originate from chord EN. Therefore, an angle at the center is 2 times an angle at the circumference. Right? Right? That's one way, right? If you want to use a longer way, you might have to use triangle MEO. Okay? MO is a radius, EO is also a radius. Okay, so this angle here, that angle, the E1 plus E2 is going to be equal to M2. But you have to start by stating that OM is equal to OE, then you say radii. Then from there you say, therefore, M2 is equal to MEO, and your reason will be angles opposite equal sides. Then after that now, you add M2 and the sum of E1 and E2, you subtract it from 180, or rather you can use exterior angle of a triangle. So O2 is going to be the sum of M2 and E1 plus E2. So there are three ways of getting getting O2. Okay? There are three ways. You can use exterior angle of a triangle, you can use sum of angles in a triangle, or you can use theorem 2 straight away. So whichever method comes into your mind based on your understanding of the question, you use that method. Are you following that? Right? Then, but you has got a question? Any question? Let's move on. Now, to do 7.2, I saw some of you had challenges with it. Okay? But it's so easy. Right? So this angle here, we got it as 110 degrees. This angle here is equal to 55. Okay? That's 55. So in my case, I'm going to, because I want to find angle S, which is this angle. So all I have to do is determine the size of this angle N. I'm going to find angle N. To find angle N, I know that this angle here is going to be 90. It's an angle subtended by diameter at the circumference. So it's 90 degrees. 90 plus 55, subtract the sum from 180, I'll get angle N. And then I'll be smiling. Okay? So, here I'll start by saying, in triangle MNE, okay, angle MEN is equal to 90 degrees. And my reason here will be angle in a semicircle. Okay? Then I'll say M2 plus MEN plus angle N will give me 180. And the reason here, because this is 5 marks, you have to write quite a lot. Sum of angles in a triangle. So what this means is angle N will be equal to 180 minus 90 minus 55. And the answer that you get there is going to be 35 degrees. So this will be 35 degrees. Are you following? Then from here, okay, just to save space, I'll carry on there. So I'm almost done. So here I'll say angle S is equal to angle N, and my reason is going to be angles in the same segment. So it means angle S will be equal to 35 degrees. Yes?
So would you not use angles in a straight line? You use from O2 you get O1, and then angle at the center is 2 times angle at the circumference.
Yeah, if you want to use angle, if you also want to use angle at center, it's fine. So you can get this angle here. Subtract 110 from 180, you get 70. This is an angle at the center. They are subtended by the same chord ME. So this angle here and angle O1, they are subtended by the same chord. And angle S is an angle at the circumference. That's an angle at the center. That's also correct. Okay, so you could approach it that way. Use theorem what? 2 to get angle S. Okay, so I'm sure you can now see that to determine angle S, there were 2 ways of finding angle S. Either use theorem 4, like how I did, or use theorem 2, like how Aryan is suggesting. Any of the 2 methods will be correct. Yes.
Is the diameter always a straight line?
Yes. The diameter is a straight line. Any other question? Right. So